Hello friends, welcome to this lecture of TOC. In this lecture, I am going to discuss the topic of language. What is language in TOC? Let us check that. So, a language L is a collection of strings. See, in TOC, the language that we basically consider is very much different from the language that we discuss in a normal computer language. In normal computer language, the language that we have has a particular syntax and semantics. That means it has some meaning. But here, when we say a language in TOC, the language is known as a formal language. And what is formal language? A formal language is basically used to formalize a language that is basically a collection of strings. That means the language that we discuss in TOC is known as formal language. And formal language simply means a language L which is used to formularize all possible strings or words that can be obtained from a given alphabet fine. So let us check what exactly it means. Suppose we have a language represented as a n such that n is greater than or equal to 0. So it is a language, and how we can formalize it? This is a formalization of a language, and how we can obtain a set of string from this language, that we have to check out. So using this identity, what I can simply do, A0, A1, A2, A3 and so on. So this A0 is nothing but lambda, which is a fundamental string. This A1 is a second string that we obtain, and with the help of this string I can generate A. This is A, and this is basically not similar to A square of mathematics. Do remember that it is not similar to the A square of the mathematics, but it is a language, and it is basically the concatenation. We have concatenated these two strings. That is what we call the formalization. Fine. Next thing is that using these two basic fundamental, whatever we are obtaining the fundamental strings here, with the help of these strings we have to obtain the all successive string. That is called the formalization. Fine. So what we can do, since we have generated a square, this is a square. So after putting a, see, a we have obtained in our previous step, and a square we have obtained with the help of this a, and with the combination of these two string we can obtain a cube. And similar, I can generate this thing. Then I can generate this thing. So I can simply say that a cube can also be generated as a, or a cube, this something like that, or this can be generated as a cube and a square, something like that. Fine. So this is what we can generate a various kind of the string from a given formalization. So this is what called the formal language. Fine. And this is how we have to generate the language in TOC. So we can say that we have an alphabet as A in this case, and if I apply a clean star over it, it will also generate lambda, a square, a cube, a4, and so on. And we have seen right here also that we are obtaining lambda, a square, a cube, and so on. So I can say that L is a subset of this thing. Fine. It is a very important relation. Fine. So L is a subset of universal language. This is the important thing that we have to remember. Now there are certain operations that we can perform over this language, and what are these? Let us check that. So operations over L. There are various operations that we can perform over this language. So operations over L. Fine. What are the various operations we can perform over L? Let us check that. So number one operation is reversal operation. So how I can perform the reversal operation? Suppose I have a language which has a string W, and I can find the reverse of it, and this W basically belongs to the language. It is a basic definition. This is the definition of the reversal of a language. Fine. And how we can understand it? Let us check with an example. Suppose I have a language like AB, ABB, ABA, BAA, BBB. Fine. This is a language. And what would be the reversal of it? Very easy to obtain. I can apply this reversal operation over each string. And it would result to as BA, EBA, ABA, AAB, and B. So this is what we obtain for the reversal or defined over this language. Fine. So let us now move to the next operation. What is the next operation? the next operation that we have is concatenation operation. So I have two languages L1 and I want to concatenate with another language L2. Then what would I obtain? I would obtain this as a string where X belongs to L1 and Y belongs to L2. Fine. For example, suppose L1 is defined as a collection of a string as A square and A cube, and L2 is defined as B square and B cube. So I can concatenate these two languages as AB square, AB cube, A square B square, A square B cube, A cube B cube square, and A cube B cube. Fine. Now the next thing is I can also write this in this fashion as BA square, BA cube, B square A, B square A square, B square A cube, B cube A, B cube is A square, and B cube A cube. So we can see that I have obtained L1 L2 as the collection of this string, L2 L1 as a collection of these string, and we can simply conclude, we can simply observe here that L1 dot L2 is not equal to L2 dot L1. I think it can be easily observed. Right? So the next operation that we can perform over the language is the union operation. So how we can perform union operation over this language, let us check that. So what is a union operation? Let us check that. We have two languages and x1 belongs to L1 or x belongs to L2. Very easy to define this. Fine. And what would the example for this? We can have L1 as AB. And we have another example as AB. So the union over this would be AB and B. Fine. This is very much clear that L union L2 would result something like this. Fine. The next operation then we for over the language that we have is the intersection operation. So the next operation is intersection operation. So what would be the definition of the intersection? We have operation X belongs to L1 and X belongs to L2. Fine. So let us understand this with an example. L1 is A, AB, A, B. So intersection would be A. Fine. And suppose if I have another example, something like this, that L1 is A, AB, and L2 as B, BA. So this implies L1 intersection L2 would result as phi, because nothing is common in these two languages. Fine. And we know that this phi is also known as an empty language. Empty language. Right. So the next operation that we have over the language would be difference. The difference operation, we have L1 minus L2, and it would result into X as a string. X would belongs to L1, but X wouldn't belongs to L2. This is a very important operation. Fine. We can understand that when L1 minus L2 is there, it simply defines that we obtain the string where the string can belong to L1, but string will never belong to L2. That is the basic idea that we have to remember. So let us take an example to understand this operation. So let us have a language as A, AB, BA, and L2 would be as B, AB, A, AAB, something like this. So what would be the operation? L1 minus L2 as we have AB, right? We would have BA, right? We would have BA, and if I take L2 minus L1, then the result would be we have B, we have A. Fine. It is very much clear. Fine. So let us move to the next operation. That is a symmetric difference. Fine. We can have the special case. We can have the special operation that we call it symmetric difference, and it is just simply the modification. It is simply symmetric difference, and it is an extension of. It is obtained basically by combining the union and the difference operation. Fine. So how? What is basically the symmetric difference? It is basically represented as this thing using this symbol, which is very similar to this symbol is very similar. I think it is you are familiar with this symbol as a XOR operation in the digital electronics. But here this is not a XOR. Fine. It is simply representing the symbol of symmetric difference. And how we can define this? L1 union, it would be L1 minus L2 union L2 minus L1. This would be the operation of the symmetric difference. Right? So I can take a simple example like AAB. I can take the example as B, ABA. Right? So what would be the symmetric difference? So first I have to take this thing. If I determine this thing, it could be AAB. We have to take the union. And I have to determine this thing, and we obtain AB. we don't have anything. Let us take this as a A. Fine. So the answer would be ABA. Fine. Answer would be ABA, and this would result into AAB, AB. Right? This is how we basically solve the symmetric difference operation over a given language. Right? So the next operation that we have, this was a 7th operation we have. The next operation that we have over the language in TOC is prefix and suffix. What is actually the prefix and suffix? Let us check that. Suppose we have a language, and in that language XY is there. Fine, XY is there. So we will call X as a prefix and Y as a suffix. Fine, we will call X as a prefix and Y as a suffix. And how we can obtain the prefix and the suffix from a given language? Let us check that, because sometimes in entrance test it is asked, fine, or sometimes during the interview or technical question it is also going to be asked. So be aware about how we can obtain the prefix and the suffix from a given language. So if we have the string, suppose a string given as 1 0 0 1. Suppose this is a language containing only one string. So what would be the prefix for that? So first thing that we have to obtain the prefix as lambda 1 1 0 1 0 0 and 1 0 0 1. We are simply first I have obtained 1, then I have combined this to 1 0, then 1 0 0 and then 1 0 0 1, and we can conclude this as that every prefix or every string is a prefix of itself. We can observe it from this example. Fine, every string is a prefix of itself. Similarly, I can find the suffix of it. What would be the suffix of it? So it would be lambda. We have to start from the end. Fine. When we find the prefix, we always begin from left to right, and when we find the suffix, we always move from right to left. It is basically the prefix, and we have to find the suffix in this way. So the suffix would be obtained as 1 0 1 0 0 1 and 1 0 0. And we can again say that every string is a suffix of itself. Fine. So this is the 8th operation that we can perform over the language. Now the last operation that we are left with is the division. How we can perform the division over a given language. So the 9th operation is you can say we are simply performing division or quotient operation. So how we can find this? Suppose it is a language and we have to divide it by some string as x. So we basically call this operation as a right quotient. Right quotient operation. Fine. So how we can define it as? We can define it as that n by x simply implies w, and wx basically belongs to language. So example would be, suppose we have a language something like that, LA, then we would differentiate with respect to this A as to obtain L. Fine. We will obtain as this thing. Fine. This is how we basically perform the operation. Fine. So similarly, in this, if we want to perform in this fashion, this is called left quotient. This is known as left quotient, and the definition would be for this would be, I think we can represent it as dl by A as entirely dl by A. We can write it as to obtain this. Right? So the definition of left quotient would be L by X. We would obtain W, and XW belongs to L. Right? And the operation, let us take the example. We have D AL by A, and we would obtain L. So these are the various operations that we can perform over the given L. So this is from this lecture of the language. Fine. We will talk about another very important topic about TOC in our next lecture.